Here, this diagram is from this problem 24, and let's consider uh, the charge on both conducting plate is the same sign. So in this case, I use the positive charges. Now consider the electric field due to this the plate at the left side here. I will use the blue color to draw the electric field line. So let's call this the EL. This is EL. Now consider the field, electric field due to this plate at the right side. I call it the ER. So from the diagram here, you can see actually these two electric field cancel one another between these two plates. So the electric field between these two plates is equals to 0. Now we can start to solve for this question. We start with the most general form of the Gauss law. This is the Gauss law. Now we start with A. It asks about the electric field between them. So in here we already know this E field will equals to 0. But let's use the concept of the Gauss law. We apply the let's say the cylinder shape here, and you can see this have the some area A, so E, E dot A will equals to this Q and close over the epsilon naught. This is the case between the plate. This is equals to Q and close over the epsilon naught A, and this Q and close, you can see from here we take this cylinder, whatever shape actually. This will give us the charge enclosed is equals to 0, so the electric field will equals to 0. This is for the case A. Now B asks about the outside of either side. So in this case, since it is symmetric, we can take another bigger cylinder that enclose some charge, and also the at the outside of this plate here. This is the case, and you can see we have two areas here which are perpendicular to the electric field line. This is the area which we will it will produce the flux. So in this case, we get E 2A equals to Q enclosed over the epsilon naught. Now we know the charge density is defined by charge Q over A, right? But you have to be careful here. You can see actually we enclose the charge from these two plate, which we have two charge density sigma. So we can conclude that 2 sigma is equals to Q enclosed over A. So Q enclosed will equals to 2 sigma A. Now we substitute inside, we get 2 sigma A over the epsilon naught. So you can see this 2A can be cancelled out. E will just equals to sigma over epsilon naught. So this is the answer for B. Now we proceed to C. What if the plate are non-conducting? For the non-conducting plate is basically will produce the same thing. So the electric field produced is the same, but the charge of the uh, plates are not need uh, to be at the surface. So remember that the in the conducting case, the charge will go to the surface, so make the electric field inside equals to 0. But for the non-conducting, the charges are not free to move, so they are not going to not necessary to be at the surface. So this is means the arrangement of the charge are not going to be the same, but basically you will get the same electric field, and between them will still have a zero field.